Hi everyone. So today's lesson is on graphing a hyperbola. A hyperbola is very similar to a parabola, except that there's two of them. So where a parabola could go up or down, a hyperbola will actually end up doing this, and there'll be mirror images, and it'll go up and down. Where we've graphed a parabola that could go right or left, it'll end up going right and left. So it'll end up looking kind of like that. One or the other. Okay? So let's go into our notes. Alright, so the warm-up says to write the equation of the ellipse, so this would be, a good point for you to kind of try to do this on your own since we just talked about it yesterday. So let's see. Assuming you are checking your answer, you'd want to identify your center. I would start off by writing an ellipse like this just to kind of get the general form of it. I would say, okay, I know it's something plus something equals 1. I know that my x goes first, so I'm going to identify my center. My center is at 2, 3. So that means that this has to be x minus 2 squared. And this would have to be y minus 3 squared. Underneath my x is how much I go left or right squared. So the distance from here to here is 1. So if I square that, that would be a 1. On my y-axis, this distance goes from 3 up to 6. So from 3 up to 6 is a distance of 3. So when I square that, I get 9. You can leave your answer like that. More often, though, you're going to see it written as x minus 2 squared plus y minus 3 squared over 9 equals 1. Okay, remember when we write an ellipse, it must always be set equal to 1. Okay, so the thing that we're going to talk about today with hyperbolas is you're going to notice that one sign is going to change. Instead of that being a plus sign, it's going to change to a minus sign, which is the key feature that's going to change this between an ellipse and a hyperbola that we're going to talk about today. Okay, so here are the pieces of a hyperbola that we're going to fill in. First off, a transverse axis is something that we're going to be asked today. A transverse axis is the distance between the vertices. Okay, so just to kind of label it on here, the transverse axis would be the distance between the vertices of the parabola. Okay, so that would be the transverse axis, that distance between. Okay, notice that I've drawn both possibilities for you. This one has a parabola facing up, and this one has a parabola facing down. Whereas over here, one's facing left and one's facing right. So they'll either both go left and right or both go up and down, but you'll never have one that goes up and right or up and left. Okay, they either both have to go along the y-axis or both along the x-axis. Okay, the center is this point right here. It's the distance between, or it's the place between the vertices. The vertices would be this and this, so the vertices are the vertices of the parabola. The foci is this point right here. Notice that just like a parabola, it's inside the parabola. It just, there happens to be two of them since there's two parabolas. Asymptotes are new in this one, so this is an asymptote, and so is this. There's two asymptotes, and remember, asymptotes are lines that we don't touch. So if you think about, the best way to think about this is when you talked in Math 1 about exponential equations. So if I were to graph an exponential equation, it would look like this. And this would be the asymptote, the line that the function approaches but doesn't touch. That's what this is. This is a line that the functions are going to approach, but they will never touch. Okay, so we'll have to graph that today to help us draw a sketch of the function. All right, go ahead and fill this in. We have that a hyperbola stretches along the axes that is written first, so that's what's really important here. So in an ellipse that we talked about yesterday, an ellipse will always have x being written first, and then your y. However, in a hyperbola, because of the minus sign, we can switch which one's written first. So notice in this one, x is written first, and notice that in this one, y is written first. Okay, and that's because of the minus sign. So in this case, this part, the y squared is negative, where in this part, the x squared is negative, and that's what's dictating what direction it goes. Okay, so let's kind of talk about some key features if we have x being written first. So my center is at h and k, which is the same no matter what kind of conic we're talking about. Over here, can you actually change these? With y should always be the k, and with x should always be the h. I just forgot to flip them. That means that your center is still h comma k. It just means that I would have to go to this equation to find h and this one to find k, not the first. Okay. Because x is written first here, this would open on like the x-axis. It would open left and right. So this opens left and right because x is written first. Okay, so I'm just going to say first. Over here, this one, because y is written first, is going to open up and down because the y-axis goes up and down. Okay, so similar, same thing when we talked about a parabola. It's just instead of going up or down, it goes both. The vertices in this would be, let's see. So the vertices are going to be h, and then it's going to be plus or minus our a value, and then it's going to be k plus or minus our b value, since we have h and a together and k and b together. However, over here, it's going to be h plus or minus our b, because notice h and b are together. And then it's going to be k plus or minus our a, because our a and k are together. That notation truly isn't going to matter. We're going to be able to find it from our graph, and it's way easier than using this notation. Okay. Our foci is the last thing. We find our foci by using a similar formula to the ellipse, except we're going to actually use a squared plus b squared equals c squared, so it's actually the Pythagorean theorem. Notice that this right here is a minus sign, which is why we use a plus sign in the equation. So yesterday there was a plus sign in the equation, which is why we used a minus sign for the foci, so it flips. Okay, so same thing over here. It's going to be a squared plus b squared equals c squared. It doesn't matter that my a and b are in the same places, because once I add, okay, so let's kind of work through a couple problems here, talking through all of it. Okay, first thing that I would do is identify the center. So because there's nothing in parentheses here or here, that means that my center is going to be at the coordinate 0, 0. Okay, so I'm going to plot a point here at 0, 0. Because this is, the 9 is underneath my x value, that means if I take the square root of 9, I get 3. So on my x-axis, I'm going to go 3 to the right and 3 to the left. Okay? Because 16 is underneath my y, then that means the square root of that's 4, and I'm going to go up and down 4. So same thing that we did for the ellipse. Okay, if this was an ellipse, I would actually connect these and then I'd be done. So that's what we did yesterday. However, this is a hyperbola, so this is actually what we need to do. Because there's going to be two parabolas, I actually need to create a box. So I'm going to create a box. So if you notice, if I fill in these corners right here, this is going to create a rectangle. I'm going to connect these with dashed lines. These are going to help us determine where those asymptotes are at. Okay. So what I'm going to do next is I'm actually going to find, let me show you. Notice that in right here I have these lines. They're linear equations, and there's two of them. One has a positive slope, one has a negative. I'm going to find those lines, and what I'm going to do is use this box. So that's why I'm going to create this box. So notice from the center to get to this corner, I go up 4 and right 3. Then I'm going to go up 4 and right 3 again from here. So 1, 2, 3, 4, 1, 2, 3. And then I also am going to go down here. If I go down 4, left 3, I'm going to go down 4 again. 1, 2, 3, 4, and left 3, and put a point. And then notice that I can connect these with a dashed line, and that would be the asymptote. And then I need to go the other direction as well. So if I go up 4 and left 3, I'm going to go up 4 and left 3 again. 1, 2, 3, 4, 1, 2, 3. And then over here I'm going to go down 4, right 3. So I'm going to do that again. 1, 2, 3, 4, 1, 2, 3. And then I can connect these points to find my asymptote, and by finding those additional points, it makes my asymptote lines a little bit more accurate. Okay, now I need to figure out where to put these parabolas, because either the parabola is going to go here and here, or it's going to go left and right. okay, the way that I determine which way it goes, I'm going to erase those so we don't get confused. The way that I determine which way it goes is by which variable is written first. So I'm going to circle this. I'm going to say because x is written first and the x-axis runs left and right, then my function has to go left and right. So I'm going to say left, right, because x is first. Okay, so then that means that I just need to stay between these lines because those are my asymptotes. I can't touch them. So my function will approach them. It'll hit that vertice point, and then it'll go this way. You want to draw it close to those lines, but not touching. So you don't want to draw something that looks like that. Okay, so it approaches these dashed lines, hits the vertice, and then continues going that way. All right, notice that again they're hitting these vertice points right here. Okay, so now I can label some things. I know where my vertice is. It was not the top and bottom, it was the left and the right. I can see that one of those coordinates is at -3, 0. The other one is at 3, 0. To find the foci, I use that formula. So I'm going to use a squared plus b squared equals c squared. It does not matter the order, but I'm always going to write the biggest first. That way, when I use ellipses and I subtract, it won't matter. So 16 plus 9 equals c squared. So that gives me 25 equals c squared. So when I take the square root, I get that c is 5. Okay, that means that when I go from the center, not from the vertice, but from the center, I would go left and right 5, because remember, it's got to be over here and over here. It's got to be inside the parabola. So 5 would be here, and I'm just going to put a star, and then 5 would be here, and put a star. That's my foci. So the coordinates for my foci would be at -5, 0, and 5, 0. Okay? The transverse axis, remember, is talking about the distance between the vertices. So if I go from this vertice to this vertice, I go 3 and 3, which means my transverse axis is 6, because that would be the distance. Okay, so that's the first one. We're going to do 3 more. Go ahead and flip over to the back side. Alright, now, what you want a hyperbola to look like is just like this, which that is what an ellipse looks like, except for the fact that that's a minus sign. So in example 2, we're going to make it look like that. Notice in that problem that it was set equal to 1. We must be set equal to 1, just like an ellipse. So in order to be set equal to 1, I have to divide everything by 16. So 4/16 is 1/4, so that means that that's y squared over 4. And this one, nothing simplifies, so that means it just stays as minus x squared over 16 equals 1. Okay, there's nothing inside either of those parentheses, so that means that it's going to be 0, 0. Okay, so when I plot that point at 0, 0, on my x-axis, because, well, it doesn't really matter, under my y is a 4, so the square of that's 2, so that means I go up and down 2. Underneath my x, the square root of that is 4, so that means I'm going to go right 4 and left 4. If this was an ellipse, I would connect those and make an oval. However, I need to make a box so that I can find the asymptotes and find the 2 parabolas. So I make my box. I'm just connecting them with dashed lines. And then I need to extend and find the asymptotes. So notice from the center, I go up 2, right 4. So if I go up 2 and right 4, I would be here. From the center, I go down 2, left 4. So down 2, 1, 2, 3, 4. And then I can connect those points. And I'm going to connect them again with a dash line since that's an asymptote. And then I'll do the same thing. I'll go up 2, left 4. So up 2, 1, 2, 3, 4. Down 2, right 4. So down 2, right 4. And then I want to connect those with a dash line as well. Okay, and those would be my asymptotes. So now I need to determine is my parabola facing up and down or left and right. So notice that right here the y is first. So I'm going to say, because y goes up and down, it's going to be up, down, because y is listed first. Okay, so then I need to, it's always hard when it's really wide, but I need to approach those asymptotes and make sure that I hit that vertice, and then do the same thing here, approach, don't touch, and hit that vertice. Okay, so I can state my vertices. I can see that my vertices are at 0, 2, and 0, -2. My foci I find by using that formula, a squared plus b squared. So a squared plus b squared equals c squared. That gives me 20. Okay. When I take the square root, I do not get a whole number, so I'm going to do this without a calculator. I need to estimate about where that is. That would be between the whole numbers of 4 and 5, because 4 squared is 16 and 5 squared is 25. So I can just graph it like 4.5. So from my center, I would go up 4.5, which would put me here. I'm just going to put a star, and then that would put me here. Okay, so the foci is a little bit harder to write now because it's a decimal place and we're doing this without a calculator and we want to be exact. So here's what I'm going to do. I'm going to simplify this radical. So we need to simplify radicals, which that would be 4 times 5. So that means that it's 2 root 5. Okay, here's the best way that I can tell you to explain this. Like we talked about yesterday, notice that the foci was moving up and down, so when I go to my center, it's affecting my y value. So that means my foci is going to have the same x value, but my y value, it starts at 0, and then it goes up and down, which is why it's plus and minus 2 root 5. Okay? You do not need that 0 in there, but I'm okay with you leaving it in there, because if it was a number like 1 or -3, then you wouldn't need it. Okay? The transverse axis is the distance, so the distance from this vertice on the top to the distance on the bottom is 4, so that would be my transverse axis. Okay, so let's try again. This one's written probably a little bit easier for us. We don't have to divide by anything because it's already set equal to 1. So I can see that my center is at -3, 1. Okay, so I'm going to plot that point. Okay. Underneath my x is a 4, so the square root of that means I move right and left 2. Underneath my y is a 25, so the square root of that means I move up and down 5. Okay, I need to make a box, so I'm going to start by filling in these corners. So go ahead and dash lines, fill those in. Okay, I need to figure out where the asymptotes are, so I'll continue this slope. I go up 5, right 2. When I go up 5, right 2, I'm actually off my graph, but I can still go up 1 more, so it's about there. Down 5, left 2, so when I go down 5, left 2, I'll be here. Okay, connect those, making a dashed linear equation. I'll go up 5, left 2, which means I'll have to go a little bit off. Left 2, down 5, right 2, down 5, right 2. Okay, and then connect those. Okay, and those would be your asymptotes. I need to decide if it's going to be going up and down or left and right. Okay, the way that I determine that is because x is listed first. So because x goes left and right, this is going to go left, right. So left, right, because x is first, you're going to want to write this down just to really make sure you understand, or if you got to look back. Okay, so if I know it's got to go left and right, then it's got to hug these asymptotes, hit that vertex, and then hug those as well. We could draw more points and make this a little bit more accurate, but we're just really focused on the sketch here. And there's where our function is. Make sure we're drawing arrows on both ends. So our vertices would be at this point and this point. So one of them is at -5, 1. And the other one would be at -1, 1. And it does not matter which one you list first. The foci, I'm going to do 25 plus 4 equals c squared. So I get 29 equals c squared. Okay, when I take the square root, that would be between 5 and 6, since that's 25 and 36. So graph a little bit like in between 5 and 6, so 5.5. Remember, go from your center. So 1, 2, 3, 4, 5.5 puts us way out here. 2, 3, 4, 5.5. So you're pretty far from your vertice, which is uncommon. Okay. So in terms of writing my foci, I notice went left and right, so that means it affected my x value. I would always go put a dot on which one it affects. So if it affects my x value, that means that I first had to be at -3, and then from there I went left and right, which is why it's plus and minus the square root of 29, which cannot be simplified, and then I went up. Okay, so again, from -3 we went left and right, the square root of 29. Alright, the transverse axis is the distance between the vertices, which, if I go back and count, is 4. Alright, last one. At this point, you could probably try this one on your own. You should be able to do it. I can help you get started. You just need to make sure that you divide by 144. You got to be set equal to 1. So if I divide by 144, I would give you much more reasonable numbers on homework and test, guys, because again, without a calculator. So I'll tell you, when you divide 9 and 144, you get 16. So that means that this will be y plus 2 squared. Okay, and then over 16. This will be at 16 and 144, it's going to be a 9. So it'll be minus x minus 2 squared over 9 equals 1. Okay, so at this point, I would try to pause it and do it on your own. Alright, so hopefully you're checking your answer right now, and I'll kind of walk it through just in case. Otherwise, you can fast forward and check your answer. Your center should be at, make sure you take the x value. So go to x, that would be a 2 comma -2. So it's not what's written first. You have to go to your x. Okay, so not -2, 2. So I'm going to go plot 2, -2, which would put me here. Okay. On my y-axis, the square, that's 4. So I'm going to move up and down 4. And then on my x-axis, I'm going to move I'm going to move right and left 3. Alright, I'm going to fill in my corners. And I'm going to go find those linear equations for my asymptotes. Connect this. So let's see. Up 4, right 3. 1, 2, 3, 4, 1, 2, 3 goes here. Down 4, left 3. 1, 2, 3, 4, 1, 2, 3. I'm going to connect all those points. Up 4, left 3. 1, 2, 3, 4, 1, 2, 3. And 1, 2, 3. Okay. I would make sure that your asymptotes extend beyond the graph. It makes them a lot more obvious. Okay. From here, let's see. I need to figure out if this is going to go up or down. Notice that y is written first, so this has to go up, down. And that's because y is first. Okay, so it's got to go up or down. I'm going to hug these asymptotes and hit this vertex and then go back up. Try not to make it V-shaped like that, but it should be a U. And then same thing here. Make sure you're drawing arrows. Make sure you're extending. Sometimes I see people who do this and just go like that. You need to extend on your entire graph. Use your whole graph, okay? Okay, so let's see. Our vertices, I can see are 2, 2. And 2, -6. Right? That would be this point and this point. Alright, make sure you have parentheses. Alright, my foci I can find by doing 16 plus 9 equals c squared, so this will be nice because it's 25. Square root means that I get c equals 5. So from the center, this one's going to be really close. So let's see, 1, 2, 3, 4, 5 right there, which means it's got to be right there. If you end up with it not inside your parabola, then you know you made a mistake. It's got to be inside the parabola. Okay? So because from the center I went up and down, that means it's affecting my y value. So again, I put that point there. That means that this one stays the same, but then it would be -2 plus or minus for the up and down, and it's going to be this. You guys can leave your answer like that. it's a little bit more accurate to actually find those coordinates. And in this case, since they're whole numbers, -2 plus 5 gives me 3. And -2 minus 5 gives me -7. I'm okay with either of those answers, though, to be honest. The transverse axis is the distance between, so 4 and 4 means that it is 8. Okay, so if you need to go back and listen to anything, feel free, but that's the general idea. Again, the big thing is that this is very similar to an ellipse, except that we have to pay attention to a minus sign, so which means we got to do a little bit more work, and it becomes really two parabolas. Okay, in your homework, you're just going to do a lot of the same. Trying to see if there's anything that needs to be pointed out. Number 4, make sure that you set that equal to 1. I think it's all hyperbolas. Yeah. So the first 6 problems are all hyperbolas, and then the last 2 are going to be writing the equation of the hyperbola. Anytime that you do that, I would start off by saying, okay, I know it's going to be something minus something equals 1, and then you can go back and say, well, what goes first, x or y, based off the direction. Okay, but it's always nice to kind of to set up a template of the answer. All right, I will be back tomorrow. Thank you.